Okay, today we're looking at section 3.1, solving systems using tables and graphs. Just so you know my personal opinion, I'm not really a table fan. I know when you guys were graphing last week, some of you were trying to use the table and you were so confused. When we just stuck to moving the graph around, you're like, that is so much easier because it's a visual thing. So I feel like tables can throw you off sometimes just because you're only looking at numbers, where when you're looking at a graph, you're looking at where it is, what it's doing, and all of that. So if I had to choose, I would definitely choose the graphing method. Some of them might just say use the table. So we'll do whatever they ask for, but I would probably focus more on the graphing if I had a choice. So objective, to solve a linear system using a graph or table. Solving a system of equations is the set of values for the variables that makes all the equations true. Two different ways, and we'll do the third way tomorrow, is graphing and using tables. The other ones that we do are substitution and elimination, and again, we're going to look at those later this week. So what is the solution of this system? You are first of all looking at two different equations in standard form. Remember, standard form has the variables on the left, the number on the right. We're used to solving using slope-intercept form. So that would be your first option, or your first method of solving is solve each of the equations for y. So when we're solving for y, we will add 3x to both sides. I always write the x first. You can write it after the 8 if you want to. And then we would divide by 2. And that's every single term by 2. And we would graph this one. Okay, so we'll put this on the graph paper. So this one crosses the y-axis at 4, and it's always up or down first. And then we would count the slope. The slope is 3/2. I'm going to write what these intercepts and slopes are, but you don't have to do that. I would just be actually looking at it doing this. So my b is 4. And my slope is 3/2. How do I do a 3/2 slope? Reverse for you, Josh. Up 3, right 2. So it's up, down first, and then right, left second. And then you would draw this in and try to use something straight. The rulers are still up there if you want to grab one. If you don't have a ruler, do more than just 2 points, because then it actually gets the line where it should be. So since I don't have a ruler on here, I'm going to go down 3 and left 2. So I'm going to put another point on there. Okay. Then we're going to solve the other one for y as well. I'm going to change colors so that it's a little more visible. So we will solve for y, so I'll subtract x from both sides and divide by 2 every term. Normally we would just look at this one. The b part is -4, so it crosses the y-axis at -4. And my slope is -1/2. So my first point will be down 4. And then from there, I have a -1/2 slope. So I'm going to go down 1, right 2. And I'm also going to go up 1, left 2, since I don't have a ruler. And I'm going to actually continue this on. I'm going to see if I have my points right. And then I'm going to draw it in. Now, I made sure that my slope of that first line was right. So from this point right here, I went down 3 and left 2 again, so I would have probably put another point on there. If you draw it in with a ruler, it's probably going to show that that's where it is. These are going to be numbers probably that you know for sure what they are. So then what we would do is name the point that they cross at, and that would be your answer. So instead of going through and doing elimination or substitution and getting it that way, we are just looking at the graph and counting. So naming this point, we'd have 4, -4, -2. And you would put that in an ordered pair, and that would name that point that those two lines cross. So graph both lines, and you should be able to name a point. Where it gets kind of iffy is if they cross at like fractional numbers, and that's why generally on these, they're probably going to give you numbers that you know what they are instead of 1/2 and 3/4 or, you know, something goofy like that. So I'm hoping that the ones they give you are numbers that you can actually go, yes, that is for sure right. I know what I'm doing. Sometimes there are answers, sometimes there aren't, and we'll get to that here in a little bit. Now, when you use a table, you're not thinking about the graph at all. You are just strictly using a table. So I'm going to set this one up. I'm going to actually put the equations above it so I don't have to keep going down the page and moving it. So here's my equations again. Okay, so in the table, you might want to write the equation in there as well. I'm just going to write it above it so you kind of know where I'm plugging it in. So y1 would be your first equation, solve for y. Y2 would be your second equation, solve for y. So I have them written directly above. Now, what you're going to try to do is pick points that you know when you plug them in, you'll get the y values. But the thing with this that I don't like is if you don't know what the answers are, you might not pick very good points right away. For instance, r's crossed on the negative side. Would you guys pick negative numbers if you had a choice? Probably not. So that's kind of why I don't really like this method, because it could take a while for you to hit the same number. Now, the answer is going to be, where are those y values exactly the same? Okay, so that's the hard part about this is if you don't know what it looks like and you haven't graphed it, you wouldn't necessarily know what numbers to pick. Okay, we did do that, so that's why we're going to narrow it down to negative numbers. But if you didn't, you would just have to keep plugging them in until you got them to be the same. And that's kind of a timely thing sometimes. Okay, so we're going to stick to negative numbers because we already know kind of where they cross. So I'm going to go -1, -2, -3, -4, and of course -5 if we need to. We would probably have chosen positive numbers and we would not have gotten this to work. And that's kind of a dislike of mine with tables, is that you don't know unless you've already graphed it. So then all we're going to do is just substitute those numbers in. So 3/2 times -1 plus 4. 3/2 times -2 plus 4. So all we're doing is plugging them in. So I'm going to grab my calculator and do that. And I'm going to use decimals here. So this would be 2.5. This would be 1, I think. That one doesn't look right. Hold on. 3/2 times -3 plus 4. Okay, yep. I didn't think that was right. So mine, that one that I got wrong was -3. I had like a -14 there. The number was so off of what the other ones were, I knew I probably did it wrong. So now I'm going to do the same thing with my y's, and I'm plugging in the same x's that I used initially. So I'm going to plug in a -1 first. Then I'm going to plug in a -2. And then a -3. So what you're looking for and what you're looking to happen is you're looking for the value that the y's are the same. So right here. And then your answer would be -4, -2, which is what we got when we graphed, but you know, that's kind of what you're looking for. Now, obviously this would be easier if you had a graphing calculator, and notice how in the book they do show the graphing calculator. We don't use those, so I wouldn't expect you to do it that way, okay? This takes a lot of time, and if you have to actually physically substitute them in yourself, that's not something that's useful time management, I guess, when you're doing these. So you probably are not gonna have a lot of table ones. If you do, you'd probably have to graph it first, and then you could specifically pick, you know, certain numbers, which again kind of defeats the purpose. So you're basically, when you do a table, you're looking for the x that you plug in to be the same y values, because that would indicate what your ordered pair is. Okay, so problem 2, using a table to solve a problem. The diagrams show the birth lengths and growth rates of 2 species of shark. If the growth rates stay the same, what age would a spiny dogfish, sorry, here it moved up on me, and a Greenland shark be the same length? So here's your Greenland shark, the growth rate, 0.75 centimeters per year, birth length 37. So what part of that changes? The length or the growth rate? The birth length would stay the same, right? And then it would grow a certain amount each year. So if we had to write an equation, we could do this. 37, wait, I'll change it to the slope-intercept way, I guess. Okay, so we're going to go 0.75x plus 37. So the 37, the birth length, is the same regardless for this particular shark, and then it would keep growing after that, and the length it grows is 0.75 centimeters a year. The equation for the spiny dogfish, the growth rate is 1.5 centimeters per year, and the birth length is less. So we're going to go y2. It would be 1.5x plus 22. So basically, the information they have given, you're just going to form equations. You're going to think what part would stay the same, what part would change. The part that changes would be the part that's the slope. Then we would go ahead and use a table, and we would do the table just like we did. I'm going to write these above it. I would probably not recommend using a table, just because we do not have the calculators. And we can do y1 and y2. So just skipping ahead just a little bit, we would plug in a bunch of numbers. If you had a calculator, you could do a table on here. Your y1 would be your first equation, your y2 would be your second equation. It would spit out the answers, and it would be super, super quick. You would scale up and down, and you would look for when those values are the same, okay? But to skip ahead so that we don't have to try so many, we're going to just choose the ones that the book did. We're going to do 15, 16, and 20. They put some in between, too. So they plugged each of these in, and they got 48.25. Again, if you were doing this on paper, it would be 0.75 times 15 plus 37, and then you'd plug a 16 in and so on. And then for the second one, we would plug 15 in again, and we get 44.5, 46, and 52. So on paper, this could be a long process if you started out with 2, 3, 4, 5. Yep.
How do you know which numbers to pick? Like,
for the table?
Yeah.
That's why I don't like tables, because you guys might choose 2, 3, 4, 5, and they're nowhere near each other. So you'd have to
keep going with the numbers.
you would have to keep going, which is again why I dislike it. You guys probably wouldn't have to do one of these on a test, just because it might take you a little while to find the numbers if you didn't start in the right place. Especially like on that first one where we knew it already crossed on the negative side, I would have probably not put negatives in there yet, you know. So you would probably, if you had to do a table, you'd do both of them at the same time, and I would probably do the table second. So I'm not going to focus quite as much on tables, but I do want you to be aware of how to do them. So we would stop when we hit that number that's the same. So this one, 20, 52. So what does that mean? Okay, the growth rate, they would be the same length when they were 52 centimeters long. And that would happen in what? This is years. 20 years. Okay, so just kind of interpreting what that means at the end. That's when those should be about the same length. Okay, problem 3, if you look at that one in the book, is strictly a calculator problem. We're not doing those, so you can skip that one. I just wanted to put it here in case you looked back and thought, I don't know how to do this. Well, we don't know how to do this because we don't have the calculators. But I do want to go through the types of answers that you will have. You might want to jot these down just because it's been 2 years since you did these probably. The types of answers that you can have: consistent or inconsistent. Consistent has a couple things going on. Consistent means there's at least one answer. Basically, it depends on the kind of graph that you have. If you have a line, you're going to have one answer. If you have a parabola and a line, you're going to have 2 answers. If you have a circle and something, you're going to have 2 answers. So it kind of depends on what you're graphing. An independent system has one solution. Basically, it means that 2 lines will intersect at one point on a graph. And that's kind of what you want to think about. So independent, one solution. A dependent system will have many solutions. If you look at that one on the graph, it's one where you graph the line, and then you graph the second line, and they're directly on top of each other, which means every single point that you plug in will be an answer to both, because they're basically the same equation. So I kind of put what you would be looking at if you graphed it, as well as what you should be thinking about in your head. So independent, one answer. Dependent, infinitely many answers. Inconsistent would be lines, for instance, if they were parallel, they would never ever cross each other, so they would have no solution. So I'm going to move it up just a little bit. So an inconsistent system has no solutions, or the lines will never cross. Some of them might look like they never cross, but you really have to see, are those lines parallel or not? They would have to be parallel to not ever cross, like ever. If they weren't parallel, maybe eventually they would cross. It just might take a little while for you to be able to see it on a graph. And that might be one of the types of problems that you guys have. They might give you a couple systems and you have to figure out what kind of solutions they have. Is it independent, dependent, or inconsistent? Okay, so here's a style of question like that. Without graphing, is the system independent, dependent, or inconsistent? So what you're going to do is you're first going to solve these both for y, just like we did on the others, just like you would do if we were graphing them. So on the first one, I added 2x to both sides. I'm also going to divide by 4. And then we'll look at that in a minute. The second one is already solved for y. The only thing we have to do to it is to divide by 8. Oops. So when you look at these, what do you notice about both of them? Slopes are the same. Which means they are parallel. Do parallel lines ever cross? No. So I'm going to say slopes are the same, which means parallel. And remember that when we were looking at parallel lines, those are lines that are inconsistent. They would never cross, so they would not have a solution. So inconsistent on this one. If you had to explain, you could just solve them and say this is inconsistent because the slopes are the same or because they're parallel. Okay, and here's a couple more and then I think we're done. So let's solve each of these for y. So on the first one, all we had to do was add 3x to both sides. That one is done. On the second one, we'd have to subtract x from both sides. Now we would have to divide by a -1/3. And do a little simplifying on this one. So what does this tell us? We have a 3x plus 4 and a 3x minus 3. What kind of lines would they be? Parallel. Slopes are the same. So m equals 3. That would indicate parallel. So this one would also be inconsistent. Now, if you had to graph them, you could still do this same thing. You'd have to graph them both. And then you'd go, oh, these are parallel, so this is inconsistent. Same for the next one. So we'll solve for y. We'll divide by 3. Y equals -2/3 x plus 1/3. Solve the second one for y as well. So here's our equations we're looking at. Do they have anything to do with each other? The slopes aren't the same, the intercepts aren't the same. These two are probably going to cross somewhere. So we're going to say independent on this one. And those are the ones that have an answer. So basically the thing that I'm looking at is the slopes are completely different. One is a -4, the other is a -2/3. Eventually those will cross each other. So that's where you get the one answer from. And then there's one more. I think this is it. Yep. Okay, so the first equation is solved already, so we don't have to do anything to that one. But let's solve the second one for y. And divide by -3. What do you notice about those two? Exactly the same. So you're going to graph the first one. You're going to graph the second one is directly on top of it. So every single answer that you pick is going to work. This one is dependent. And that's what happens when the equations are exactly the same and you have infinitely many answers. Okay, and that kind of wraps it up. So just kind of a recap. We looked at how do you graph lines again. Slope-intercept form is what we're looking at. And when they cross, decide how many answers they have. If they cross in one place, it is independent. If they cross exactly the same, like if the two lines are exactly the same, it's dependent. If they are parallel, they will never cross, so those would be inconsistent. I'm not really into the tables unless you would have a graphing calculator, because you may start in a definitely wrong direction picking your ordered pairs that you're plugging in, and it might take you a little while to do. So I definitely like the graphing method better, but I just want you to know that if you did have a calculator, you would be able to find those answers pretty quickly, because the calculator would graph them and the calculator would also give you a table that you could just look at. So I'm not really focusing quite as much on the tables, just want you to kind of be aware that it's there for you.